All right, today we're going to take a look at section 4.6. It's the quadratic formula and the discriminant. Okay. All right, 4.6, the quadratic formula and the discriminant. Hopefully you've used the quadratic formula before. Maybe you even learned it to a song. Here is our quadratic formula. If you learned this to a song, it was most likely to the tune of Pop Goes the Weasel. You can join in with me, but let's go ahead and sing it once. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That was beautiful. You will need to know the quadratic formula. And sometimes I make, in years past, sometimes made the assumption that people knew it pretty well. And that's not always a correct assumption. And that's why, as silly as the song is, it can be a really good tool. Because if you don't know what the quadratic formula is, unless you're going to derive it, and we will do that tomorrow, unless you're going to derive it and you don't want to do that every time you want to use it, it's not a very valuable tool. And in fact, you're going to mess up all your problems if you do it incorrectly. So we're going to sing it one more time. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I fully expect that this YouTube video that I'll be posting is going to go viral with videos of me singing twice now. Sure, that's going to happen. But it can be used to solve all quadratic equations as long as the quadratic equation is in the form where it's set equal to 0. So standard form. So ax squared plus bx plus c is equal to 0. So we've got our a, we've got our b, and we have our c. A is always the coefficient on the x squared, b is always the coefficient on the x, c is always the constant. Sometimes one or maybe two of those are missing. If they're missing, you just have a 0 in that spot. All right, let's go ahead and so this is an alternative to solving by graphing, to factoring, and to completing the square. All of those solve quadratics just like this does. However, graphing and factoring don't always work. All right, first problem. You should observe, hopefully, that this is not set equal to 0. So do not interpret the 16 as c. It has to be set equal to 0 first. So we have to bring that 16 over, so we have a negative 16. Now I can and should identify my a, b, and c. A is our coefficient on the x squared. I don't see a number there, so I know it's 1. It's not a 0 because the x squared term exists. The b is 6, and the c is negative 16. So if we're trying to figure out what x equals, let's go ahead and use our formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I'll simplify that in just a second. All right, so now we need to go ahead and simplify that. And I'm going to start with simplifying what's inside of the square root. So 6 squared is 36 minus 4 times 1 times the negative 16. Oh, so negative 4 times 1 is, of course, negative 4, but negative 4 times negative 16 becomes positive 64. It's all over 2. So inside the square root, I now have 100. Let's continue simplifying by simplifying that square root if we can. And we certainly can in this case, because the square root of 100 is 10. Now there's no square root left, we have no I, anything of that nature, so we're going to be able to give the two answers, and so we need to do that. So we need to take negative 6 plus a 10 divided by 2, and then we'll have to take negative 6 minus 10 and divide it by 2. If you want to break it down and write them both down so you can see them if that's helpful, then do that. So negative 6 plus 10 is 4. So we have 4 over 2 simplifies to 2. Negative 6 minus 10 is negative 16. Divided by 2 is negative 8. So there's our solutions. 2 and negative 8 satisfy the original equation. Now we could have solved that in any other method, but there are some occasions where we really will want to use quadratic formula. This is one I would have probably personally solved it by factoring, but you can't always rely on factoring. Let's try, we're going to do a few more of these. All right, so 2x squared plus 25x plus 33 equals 0. This is one where it does end up factoring. I know that just because I know what the answer is, but it wouldn't have been maybe as easy to factor. So this is one where maybe we choose not to factor it. It's not a great completing the square problem because there's a lead coefficient. So this is maybe a prime example of when we might want to use quadratic formula. It's already set equal to 0. If any of them are negative, make sure you get the negatives written down. So that is important. And now we can go ahead and plug it into our formula. X equals negative b. Some people in the song, instead of singing negative b, they say opposite of b, just in case b was negative. So a negative negative, of course, would turn into a positive. This wasn't a negative, so negative 25 is not a problem. Over b squared minus 4 times a times c. All over 2 times a. Big enough numbers, maybe you even want to pull out the graphing, or not a graphic calculator, just a calculator in general. 25 squared, I believe, is 625. Sorry, my calculator is not wanting to power on. Okay, so what do we get? 361. So square root of 361, what is the square root of 361? So square root of 361 is 19. So we have negative 25 plus or minus 19 all over 4. We can simplify that further. Negative 25 plus 19 is negative 6. So negative 6 over 4 becomes negative 3 over 2. Negative 25 minus 19 is negative 44. Divided by 4 gives us negative 11. I would rather have fractions than decimals. So let me switch colors here. I didn't show as much of my work on this problem, but the 25 squared is 625 minus 4 times 2 is 8. 8 times 33, 263. 264, sorry. Yeah, sorry, that should have been a 264, not 263. And so 625 minus 264 is where the 361 came from. All right, let's take a look at another kind of unique case. Here's an example that my default might not be to use quadratic formula, but I want to show what happens when we use quadratic formula on this problem. X equals, oh, here is a negative b value. So a negative 16 is going to turn into a positive 16. Also, when b is negative and you square it, I see a lot of people make a mistake. Make sure that when you square b inside of your square root, since b was negative, it needs to be in parentheses before you square it. If you don't use parentheses and you square it on your calculator without parentheses, your calculator will tell you it's a negative number. But when you square negative 16, you get positive. You can only believe your calculator when you plug it in correctly. So we're going to take negative 16 squared, which is 256, minus 4 times 1 times 64. And we get 0. The square root of 0 is 0. When you take 16 plus 0 and you take 16 minus 0, you just get 16. 16 over 2 is 8. We only have one answer to this problem. It is possible, remember, to only get one answer. That just means the vertex of the parabola was the x-intercept. It was the only x-intercept. It is possible to only get one. I want to look now, we're going to do 2 more examples using this where we get answers that don't turn out as nice. All right, so we're going to look at this next one. 3x squared plus 5x plus 1 is equal to 0. Our 3 is our A, our 5 is our B, our C is our 1. Negative B, so negative 5 plus or minus the square root of 5 squared minus 4 times 3 times 1 all over 2 times 3. $25. So 5 squared is 25. We get 25 minus 12. Because 4 times 3 times 1 is 12. 25 minus 12 is 13. Can that one simplify at all? Well, square root of 13 cannot simplify. And there's nothing else that can be done. So we would stop at that point. There is our answer. Yep. Consider a completely different problem. I don't want you to be confused where this came from. I'm just making something up because I want to make sure to prove, or to, not prove a point, but kind of, I guess. So this, what I just wrote in orange, is not the solution to any of the problems we've just done. I want to be clear about that. But what if we did the quadratic formula and we ended up with something like this? Can this be factored further? You have to consider this constant, the coefficient in front of the square root, and the denominator. Can they all be divided by something? They could all be divided by 2, so we would do that. Become a 1, that would become a 3. So then our final answer would have been negative 2 plus or minus 1 squared of 5. I don't need to write the 1 over 3. It would have simplified to that. I didn't have to worry about it on the example we just did. On the problem we just did, what happens, once again, I'm just going to make something up for a second. If that was a 6 instead of a 5, would I have been able to simplify? You would have had to consider that number, the coefficient in front of the square root, which isn't written, so we know it's a 1, and then the 6. Can they all be divided by something? No, so that would not have simplified. All right, another example, and then we're going to talk about the discriminant. All right, so you should observe a number 5. It's not set equal to 0. That first needs to happen. So I have to add the 13 over. A is 1, B is negative 4, C is 13. Negative 4 becomes positive 4. Once again, be careful to use parentheses around the negative 4 when you square it. So we're going to now look inside of that square root. Negative 4 squared is 16 minus 4 times 1 times 13. In total, we get negative 36. We have a negative inside of a square root. Prior to Monday, we wouldn't have known what to do with that. But because we learned about complex numbers and imaginary numbers on Monday, we do know how to work with square root of negative 36. What does the square root of negative 36 simplify to? Well, think of that as square root of negative 1 times the square root of 36. Separate the negative from the number itself. Square root of negative 1 becomes I. Square root of 36, simplify it if you can. We can in this case. It becomes 6. So now I have 4 plus or minus, and that's just 6i over 2. And similar to before, can you simplify that? Well, you look at the 4, you look at the coefficient, and you look at the 2 in the bottom. I can divide them all by 2. So a 2, a 3, and a 1. So I get 2 plus or minus 3i. It's over 1, so I don't need to write the denominator. Those are the solutions. 2 plus 3i and 2 minus 3i. That's how we use the quadratic formula, but the title of the section also said the discriminant. So what is the discriminant? The discriminant is that which was in the square root, the b squared minus 4ac only. Why do we call that the discriminant? Discriminant sounds a lot like discriminate. And in a way, that's what we're doing. We're not looking down on any of these quadratics, but it is helping us to discern what type of quadratic we're going to have. So a discriminant allows us to kind of categorize the type of quadratic that we have. For example, look back at the last problem I just did. What did my discriminant end up being? Negative 36. Because it was a negative, what type of answer or answers did I have? Imaginary, or is more specifically complex numbers. Did I have any complex numbers when the discriminant was positive? No. Look at number 4. What was our discriminant there? 13 was our discriminant. It was positive. We did not get complex numbers. They were real numbers. But our answers were, in that case, irrational, while sometimes we get rational answers. Notice our discriminant up there was 361. What was true about 361? It's a perfect square. Because it's a perfect square, what type of answers did we get? We got rational answers. Isn't 0 also a perfect square? Yes, and what was our answers? Oh, well, there's only one of them, but it was rational. Let's go back over here. Here our discriminant was 100. That was also a perfect square, and so our answers were rationals. Go back to number 4 again. 13 was not a perfect square. Were our answers rational? No, they were irrational. So what we can now do, based off of that discriminant, is if we were just curious what type of answers they were, but I don't care so much about what the answers are, just the types, we can discern that without doing the entirety of the quadratic formula. If b squared minus 4ac, let's categorize these. If it was positive, or in other words, greater than 0, and it was a perfect square, what did we have for answers? Well, there were 2 of them, and they were both rational. So we could say there were going to be 2 rational roots or solutions. When b squared was positive, but not a perfect square. We still had two answers, but they were irrational. When b squared minus 4ac equaled 0, what did we have for roots? We had one of those up here. Question number 3, we had a 0. We ended up with one answer, and it was rational. It also happened to be an integer, but that's not always the case. And then lastly, what about when the discriminant was negative? We had complex numbers, and there were two of them. Two complex roots. So if for some reason we just wanted to know how many roots there were and what types they were, whether they were rational, irrational, or complex, but I didn't actually need to know what the roots were, I could do just that discriminant, and based off of whether that discriminant's positive, 0, negative, and if that positive one is a square or not, we could determine what type of roots they are. You will have some questions on your assignment that do ask you about the discriminant. Yeah, in between my answers up here, yes. Yeah, so on question, like this question right there that was just posed to me, this symbol right here. Yes, that's my and symbol. Yep. The assignment is page 270, number 16 to 30, the evens.